Good morning, students. Now we are going to study today the how to write the Lewis dot structure of the molecules. Now Lewis in its theory denoted the electrons by dot. The electrons are denoted by dot in the Lewis theory. We already see some structures, dot structures of Lewis. Now, which are the steps to write the structure of Lewis dot structure? Now, in this chapter, chemical bonding, it is given steps to write the Lewis dot structures. Now, the first step is always count the valence electrons of every atom or each atom present into that molecule or ion. Now say add the total number of valence electrons. Valence means outermost shell electrons which are taking part into the bonding. So add the total number of valence electron of combining atom in the molecule. Now, this step is very well understand by taking the example. Now, for example, write the Lewis structure of nitrite ion, NO2 minus. Now, in this nitrite ion, there are totally 3 atoms, 1 nitrogen and 2 oxygen, and there is one that is negative charge on this ion. Now, during counting the total number of electrons, one extra electron or additional electron is counted for this negative sign. And if there positive ion or positive sign on that ion, then subtract one electron and then count the total electron. Now, count the total number of valence electrons of nitrogen atom and oxygen atoms. Now there are 2 oxygen atoms. So 2 oxygen atoms and 1 electron additional for the additional negative charge. Now see, the atomic number of nitrogen is 7. So the electronic configuration of nitrogen is 1s2, 2s2, 2p3. But 1s2 electrons are not shown here because they are not the valence electron. This second shell electron, these are the 2 orbitals in the main second shell. There are the 5 valence electrons. And for oxygen, the atomic number is 8. So the electronic configuration is 1s2, 2s2, 2p4. But here 1s2 electrons are not shown because that are the not valence electron. So these 6 electrons in the second shell, outermost shell, there are the 2 plus 4, 6 electrons. And this 1 electron is there. Plus 1 electron. Now there are the 2 oxygen atoms. So multiply this by 2. So how many total electrons are there? For nitrogen, these 5. For oxygen, 6 multiplied by 2 because 2 oxygen atoms are there and 1 electron for the negative charge. So totally there 5 plus 12 plus 1, that is equal to 18 electrons. Now these 18 electrons are, we have to shown in the electron dot structure, Lewis structure. Now the second step is that write the skeletal structure of molecule. Now what is the skeletal structure? Only show the atoms present in the that is molecule. Now this nitrogen is the central atom and these oxygen atom are there. Now these oxygen atom and nitrogen atoms are joined by a single bond. Now this is only the skeletal structure. This is not the final structure. Then draw a single bond between the atoms. Now we show here the single bond between the oxygen, nitrogen and nitrogen oxygen atom. The next step is add remaining electron pairs to complete the octet. Now see, for one single bond there are the one electron pair, that means two electrons, and here also two electrons. Totally 4 electrons are already shown. Now out of the 18 electron, 4 electrons are shown here. But see, the nitrogen does not complete its octet still, because there are only the 4 electrons. So, what is then structure, electron dot structure of this nitrate ion? Remaining electron, how they are shown? If we show the 6 electron on this oxygen, both of the oxygen, then oxygen get completed the octet. Now 6 plus 6, that is the 12, and these 2 and these 2, that are 12 plus 4, 16 electron, and 2 electrons if we show on nitrogen, 18 electron there. But nitrogen does not complete its octet. So such time when one of the atom does not complete its octets, there must be the multiple bond, that means double or triple bond is there. Now how that is we satisfy both of the atoms octet? Let us see. Now see the fourth step. Which is the fourth step then? If octet is not complete, if the any atom do not complete its octet, then what we have to do? Form means there we have to put a multiple bonds between the atoms such that octet of each atom is complete. Now what we see in the skeletal structure? Now see, this is our skeletal structure. I draw first. This is the skeletal structure. If I show the what 5 electrons of nitrogen we have to show, that is the valence electron, and 6 plus 6, that is the 12 electrons for the oxygen, and 1 electron is there of the negative charge. If I show these electrons, suppose this nitrogen share its 1 electron with oxygen, 1 electron with this oxygen, and remaining 3 electrons of nitrogens are there. Now how that are shown? If we shown 6 electron on this oxygen, suppose 1 2 3 4 5 6, then this extra electron is there, 7th electron for this oxygen, so that is not such. And again here if we show the 6 electrons, now see this 6 and this 2, this completed its octet, this oxygen completed its octet, this oxygen is also completed its octet, both oxygen completed octet. But on nitrogen there are only 4 electrons, and the remaining, that is the 3 electrons of nitrogens are still remaining there, and again 1 electron for the that is the negative charge. So 4 electrons they have to remaining there. Then how that is we show? So for such time you add 1 bond or 2 bond between the atoms. Now see here, this is the structure of nitrate ion. Total 18 electrons we have to show. Now this in this structure, this oxygen completed its octet. Here is the single bond between nitrogen and oxygen, and this oxygen also completed octet. See here, 1 2 3 4 5 6, and these 2 electrons, that is 8 electrons of oxygen are already completed. Now this nitrogen have 5 electrons of its own valence electron, and 1 electron is for the its negative charge of electron. So 5 electrons, how there are 5 electrons? 1 2 3 4, and these 5, and this remaining 1 electron for the negative charge. In this way here also nitrogen complete its octet, because here is the double bond. So these electrons are belongs to that of nitrogen also. So these 1 2 3 4 5 6 7 8, nitrogen also completed its octet by putting 1 bond extra into this one of the oxygen and nitrogen, all the three atoms completed their octet. But if we put only the single bond, then that is not possible. Now these are two electrons remain as the lone pair on that nitrogen. They do not take part into the bonding, and on oxygen also both of the oxygen there are the lone pair of electron. In this way, this is the Lewis structure. It can be drawn in this way. Now here is the double bond, 4 electrons are there. So here is the double bond between oxygen and nitrogen, and here only 2 electrons. So single bond is for this another oxygen and nitrogen, and all the valence electron, remaining electrons are shown by the dot. This can be drawn in this way also. If we put the double bond between this nitrogen and this oxygen, then here is the single bond and electron can be shown in this way. Now here 4 electrons on the double bonded oxygen. So show here 4 electrons, and 6 electrons on single bonded oxygen. So show the 6 electron. So this structure can be drawn in this way or in this way or in this way. Now next rule is that for polyatomic ions, now this is also the polyatomic ion, more than 2 atoms are there, so it is the polyatomic ion. For polyatomic ion, the least, that means less electronegative atom is the central atom. You know the electronegativity. Electronegativity means the power or tendency to attract the shared pair of electron towards itself. So oxygen have the very strong power to attract the electron. So oxygen is very electronegative atom than the nitrogen. So I show here nitrogen as the central atom and oxygens are around this. So next rule is for polyatomic ions, the less electronegative atom is the central atom. For example, in this nitrous ion, NO2 minus N is the less electronegative than oxygen. So it is the central atom. If there is SO4 2 minus, such polyatomic ion is there, then sulfur is least electronegative than oxygen. So sulfur is the central atom in the structure of SO4 2 minus. In this way, these are the steps to draw the Lewis dot structure, and by taking the example of this nitrate ion, we very well understand that steps. Now see the blackboard. Let us now solve the problem 5.2. Now in this problem, we have to draw the Lewis structure of carbon monoxide molecule. Write the Lewis structure of carbon monoxide CO molecule. Now how we can draw the structure? Now go by the steps as we follow for the last example. Now step 1 is count the total number of valence electron of carbon and oxygen. Then how we count the valence electron? First we have to know the atomic number of every atoms. Now carbon have the atomic number 6 and oxygen have the atomic number 8. Then the electronic configuration of carbon is 1s2, 2s2, 2p2. But 1s electron we not shown because that are not the valence electron. So totally carbon have 4 valence electrons and oxygen have the electronic configuration 1s2, 2s2, 2p4. Here also 1s2 electrons are not the valence electron. So we only show here 2s2 and 2p4, that is the totally 6 valence electron of oxygen. There are totally, now see in the carbon monoxide molecule, there are the 14 electrons we have there for the carbon monoxide molecule. They give here 14, but there is only 10 electron because 4 plus 6, that is equal to 10 electrons are there only, not 14 electrons, because this valence electron of carbon are only 4 and the valence electron of this oxygen are only the, that is 4 plus 2, 6. So totally 10 electrons we show there, valence electron. Now see how write the skeletal structure, the second step. Write the now I add here second and third step. Now write the skeletal structure and draw the single bond between them. Now how we can write the skeletal structure? Carbon, single bond, oxygen. Now I show here that are the 6 electron of oxygen and 4 electron of carbon in this way, 1, 2 and these for the single bond. But see here, the 4 electrons of carbon and 6 electron of oxygen are shown here, this 10 electron. But by drawing such structure, only oxygen completed its octet. Now see, totally there are 8 electrons for oxygen, but carbon have only the 4 electrons. Carbon do not complete its octet. Then at that time what we do? We do that we put the multiple bond between that atoms. Now if we put only a single bond, think that only, if we put double bond, then how many electrons for carbon here? 1, 2, 3, 4, 5, 6 on putting the double bond also. But we have to complete the octet of carbon. So we must put their triple bond between carbon and oxygen. For putting the triple bond, there must require, that is the 6 electron between them, and this 6 electron and this 2 electron, carbon completed its octet. And also the oxygen, if we put these two pairs as the 1-1 bond, that means there are the triple bond, so oxygen may also complete its octet. Now see, but on drawing the single bond, carbon does not complete the octet. So draw the triple bond between carbon and oxygen so that they complete the octet, both oxygen and carbon atoms also. Now see here, I put here, that is the 6 electron between carbon and oxygen. So these 6 electrons are having, that means there are the triple bond between them. And this carbon also completed its octet. Now this 6 plus 2, 8 electrons, oxygen also completed its octet. 6 plus 2, 10 electrons are there, both completed octet. So there must be the triple bond between carbon and oxygen in the carbon monoxide molecule, and only one lone pair are on that atoms. In this way, this is the Lewis structure which satisfies the octet rule also and Lewis theory also. Both of the atoms completed their octet by drawing such structure, by putting the triple bond between carbon and oxygen. Both have completed their octet. So this is the final structure of the carbon monoxide molecule. Now let us see some Lewis dot structure for some molecules and ions. Now see, the first molecule is the hydrogen molecule. You know that hydrogen have only one valence electron hydrogen atom. So there are the two hydrogen atoms. Both have one valence electron. If they share their valence electron, then both completed their duplet as that of the helium, of the inert gas helium. So they share one electron and form a single bond between the hydrogen atoms. Now this is the Lewis dot structure of hydrogen atom, this or this. Now see, oxygen molecule. Oxygen have 6 valence electron because atomic number is 8, but the valence electron are 6. So both oxygen have the 6 valence electron. If they have to complete their octet, they must share 2 electron with each other. If they share the 2 electrons, there must be the double bond between the 2 oxygen atom. Their 2 electron they share, and in this way there is the double bond, and both oxygen atom completed their octet in this way by sharing the 2 electron. Now see, this oxygen atom completed its octet because these 4 electrons are belong to this oxygen, as well as these 4 electrons also belongs to this oxygen atom. Now see, around each oxygen atom there are 1, 2, 3, 4, 5, 6, 7, 8 electron. Here also 8 electron for this oxygen atom. Both satisfied their octet. So this is the Lewis dot structure. This is the Lewis dot structure of oxygen molecule. Both have four, that is the lone pair, two lone pairs and four totally electrons of the lone pairs. In this way, this is the Lewis structure of the oxygen molecule. Now see the structure, Lewis structure of ozone molecule. O3 is the molecular formula of ozone. Now each oxygen in the ozone, there must be 6 valence electron. Now here they are satisfy each octet by that is sharing the electron. Now this first oxygen, see this first oxygen is there. Suppose this is second oxygen and this is the third oxygen. Now this first oxygen completed its octet. Now see here, this oxygen atom 1, 2, 3, 4, 5, 6, its electron, and 2 electron of this oxygen atom. That means this oxygen share, that is the this 1 electron pair with the another 2 electron they share, and this oxygen completed its octet. 8 electrons are there. Now see for this second oxygen atom, these 4 electrons are also belong to this second oxygen atom. So it have totally how many electrons around the second oxygen? 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. But I put here the positive charge. Why I put here the positive charge? Because oxygen atom its own have 6 electrons are there. 1, 2, 3, 4, this 5, but 6 electron is not shown here. That electron, oxygen itself give both of these electron of its own to put the single bond between them. This electron is not of this third oxygen. This is of this second oxygen. It completed its octet, but it give its both electron for this single bond. So positive charge comes on that, because this only one oxygen shares these both of the electrons for bonding between them, single bonding between the second and third oxygen molecule. Now see, on the third oxygen molecule there negative charge I shown, because this oxygen have only 6 electron, 1, 2, 3, 4, 5, 6 its own, but this 1 electron for bonding the single bond, this electron is taken from this oxygen. So extra electron is there. It also completed octet. 1, 2, 3, 4, 5, 6, 7, 8. Its octet is also completed. But extra electron comes from the second oxygen atom for bonding. So it have the negative charge. So draw the Lewis structure in this way, or in this way by putting the double bond between first and second oxygen atom, and by putting the single bond between second and third oxygen atom, and another electrons are shown by lone pair. But as this oxygen shares both of the electron of its own, so positive charge on this oxygen, and it have extra, its electron is taken from this oxygen, so a negative charge on the third oxygen atom. Now see the next structure, that is the nitrogen trifluoride molecule. Nitrogen have atomic number 7. So 5 valence electrons are there of nitrogen, and fluorine have atomic number 9 and it have 7 valence electron. Fluorine have 7 valence electron. Now the valence electron of each fluorine atom, there are 3 fluorine atoms. Valence electron of each fluorine atoms are shown by this dot 6, and this is the 7 of bonding with nitrogen. This is the 7, this is the 7th. But nitrogen also share its 1, 2, 3 electron totally with every fluorine atom. But nitrogen have the 5 valence electrons. So 2 electrons are shown here as a lone pair. Now see, by drawing such, this fluorine completed its octet. This another fluorine also completed its octet. This third fluorine also completed its octet. Now nitrogen also completed, because this shared pair of electrons are also belongs to that of the nitrogen. So nitrogen have totally 8 electrons, 6 electrons of bonding, and one pair is of the non-bonding, that is the lone pair. In this way, in this structure, nitrogen trifluoride molecule, every atom satisfy their octet. It may be shown by this or by putting the single bond between the nitrogen and every fluoride that is the atom, and by showing the remaining lone pairs on the three lone pairs of electron on fluorine and one lone pair on nitrogen. In this way we can draw the Lewis structure of any molecule. This is for practice. You may do the practice at home. If you like this video, share with the other students and subscribe, and tell them to subscribe on the red button. Thank you.